Hey guys, so I'm going to talk about audio buffers and just also basic audio playback in this tutorial. This might be a little weird because my computer audio is broken, as in I can't use the laptop speakers, and I can't use Bluetooth audio output while I'm recording this. So I won't be able to hear all the sounds I'm making, so it's an experiment, but let's try this out anyways. Um, so we've been doing everything with jitter objects and basic max objects, like jitter, or jit, I guess I should say. Or like metro is just a basic max object. We're going to work with MSP objects, which if you remember is the audio library of Max, and it has its own logic and stuff, and it can get pretty complex. I'm going to give you more of like a high level jump in. Right off the back, we can just make an object called SFPlay, and if you remember, in the same way that JIT, if it has basically JIT equals jitter, and that tilde symbol equals MSP. So any object with this tilde at the end of it means it's part of the MSP library. And you can see it has this kind of yellow patch cord, which is referred to as a signal. I'm going to build some other things. There's an easy ADC object, and there's also an easy DAC object. Which stands for analog to digital and vice versa. But these are useful for two things. They are basically our computer's input and our computer's output in regards to sound. This is our output, this is our input, little microphone, little speaker symbol there. If you go to Options, Audio Status, this brings up a little thing that shows what our input device and what our output device is. So if we had a sound card plugged in, which we'll cover in class sometime, we could hook up a microphone to it, and I have this virtual sound driver called Soundflower, so I could use that as an input or an output. But this is where you would change things if you wanted to use some other hardware in terms of bringing in an audio input or having audio output. And one thing about this stuff, about this MSP stuff, is you have to turn it on and off. And the easiest way to do that is with either of these objects. If you click on it, now it's on. Basically, your Max will produce sound. If you turn it off, all the signals stop, and it will not produce sound. Yeah, that's kind of it. So I'm gonna make another object called meter. And this just shows a meter indicator of audio that's coming out. So this will hopefully at least let me see. I guess I only need one there. This will tell me that audio is coming out, so I just have to you have to trust me on that. But SFPlay is a really simple object where we can say read. Is it read or is it open? Sorry, I gotta check here again. Open. We can open a file. I'll turn the audio on now. I'll choose my favorite song in the world, Bills, Bills, Bills by Destiny's Child. And now when I make a toggle and hook it up, and you can see it says open, opens file, int plays Q, 0 stops. So it's what's saying is 1 plays it and 0 stops it. And you're not hearing anything. You can see that there's a signal coming out because peak indicator right here is going on. But once I hook it up here, so you should have heard the song playing. And basically this is a stereo, we're reading it right now, not as a stereo signal, as a mono signal, but this is our stereo configuration for a computer's laptop output. Audio out channel 1, audio out channel 2. I think if I gave this the argument of 2, wonderful, and I hover over here, you can see that now it's a stereo signal. So if my audio file is stereo, it'll now read that. I could make another one of these. I have to reopen the file. And that is kind of the simplest way to do that. You can just play an audio file. You can also give it arguments like loop 1. The audio file will just keep looping. You could also hardwire that in, or hard code that in. You can say pause. You can say resume. And those are pretty self-explanatory. You can also do this. There's another object called SFRecord. And I believe it works just about the same way. You can see we're using now the Easy ADC. It's getting the microphone that you're hearing my voice through. And if we hook it up to here and we tell it's a 2-channel input, we can open a file. I'll build this out so that you can see what's going on over here. And we'll use this, and I'll grab 2 of these. And I'll make it 2 channels. And if I say open, I have to create a file that it's going to save to. I'll save it to my desktop as test lip. It's an AIF. I guess I could save it as a wave audio file. And once I start talking, you're not hearing me do it. I'm recording the file, and then I stop recording the file. Now, I believe, once I start talking, you're not hearing me do it. I'm recording the file. So yeah, that is the quick and dirty way of playing and recording sound files. And they're totally viable. It's just like there's not a ton of stuff to do. Well, I want to show you some cooler tricks where I have a little more fun with audio. Let's just get back our easy DAC object here. All right. And I'm going to work with an object called buffer. And buffer works a lot like the JIT-GL render object from our last tutorial. And essentially, the way it works is we have to give it a name. I'll give it the name lip. And what we are going to do is we're going to load, this buffer is a container. We're going to put audio information into this buffer. And there's a whole series of other objects that work with whatever is stored in our buffer and then know to work with this buffer because they share the same name. So I'm going to make an object called Waveform, a buffer viewer and editor. Perfect. I'll give it the name lip. And I realize that that actually is not going to work. I have to give it this argument, buffer name lip. And we are not seeing anything, nor should we, because we haven't put anything in the buffer yet. One argument we can give buffer is how long it should be, and we can do that with milliseconds. So I can say if I want a 5-second buffer of audio information, I can give it the argument 5,000 milliseconds. And now you can see we have a buffer with 5,000 milliseconds. This waveform object is showing us that. We can also lock the patch and double click on buffer, and that would give us another viewpoint of that. But I'm going to read something into it. So I'll say read. And I'll choose bills, bills, bills. And you can see that the song has loaded into the buffer. This is we've stored it in there. Although one thing that's different is it automatically crops the audio file to fit the buffer size. So we're only getting the first 5 seconds of the song. Alternatively, we could use the message replace. And what's nice about replace is it'll override the length of the buffer and fit it to the full length of the file that we're loading in. And now you can see like we got 128,000 is halfway through the file, and our waveform is absolutely massive in terms of information. But we have this buffer filled with our audio information. Now we get to start playing with it. Really simply, we could do the play object with a tilde and call it lip. And this is an object that is designed to work with the buffer. Position-based sample playback. Based on, you can see right here, there's a buffer play me 1000. I guess you could read something in there. And this has the same name, much like we have set up here, and all these arguments are how we can work with it. So it's actually pretty simple at SFPlay. I believe, I'm going to get that meter object here. You know, we can say loop 1, and I think it's the argument start and stop. Or message, I should say. I'll actually just type that in, that loop 1. And you're not hearing it, but you can see that the sound is coming out here. And if I hit stop, it'll stop. So let's actually listen to that a little bit. One thing you'll notice if I hit start again is it's starting from the beginning of the song. So stop actually stops everything. We could also use pause and resume. So now we can pause it and resume it. And this is like all pretty fairly basic, you know, like it kind of works the same way. Although one thing that's fun is we can also say, we can give start some arguments. So I could say start 1000, 3000. And what it'll do is it'll play whatever's in the buffer from the 1000 milliseconds to 3000 milliseconds. So basically 1 second to 3 seconds. Might have gotten that wrong. Let me look at the help again. Right, I think I have to give it 3 arguments. I also have to give it 2000, because I have to tell it how long I want it to take from there to there. So now I'm saying play from 1 second to 3 seconds over 2 seconds. Oh, I know what's happening because I can't hear it. It's looping. I'm going to turn loop off. So there we go. It played from 1 second to 3 seconds over 2 seconds. Now, one thing that's fun though is the reason I got 2 seconds is because that's the difference, or 2000 milliseconds, that's the difference between 1000 and 3000. But if I wanted it to play twice as fast, I could have it do that over 1 second. And maybe we'll loop that just to hear it. And if I wanted it to play at half the speed, I could have it happen over 4 seconds. So this is just a different way of interacting with the sound file, and it becomes more dynamic. You know, you could have it so that you could always have it be a random. Well, actually, let me take a step back before we even get there. Another object that's usually helpful is the info tilde object. And if I say lip and I give it a bang, it'll return a bunch of information about what's in our buffer, such as number of channels, the file name, if we loaded the file name, the total time. Some of these I don't use. I don't even know what sustain loop start is because I'm not sustaining anything. Anyway, but the ones that I use most often are getting the file name and especially the length of time. And then channels is not a bad thing to know, although usually it's... And there we go. So I could make a random object, and I could have the argument of the random size. I'm going to give it a 0 point. That'll just tell it random that it's going to give me a float. If I bang that again, now I'll get a random number somewhere in that range, and I could say plus 2000. And I'm going to clean all this up a little bit. And I could pack that together. And I could say message start $1, $2, 2000. No, let's do 4000. So it's always at a slow sound. And now we're using information about what's in the buffer to create something that'll randomly play back a 2-second sample randomly from the buffer over the course of 4 seconds. So we get like this 50% speed thing. So yeah, that's pretty fun. I have a lot more fun with, maybe I don't need to get rid of all, I don't need to get rid of that yet. I can get rid of this though. Ah, shit. Keep that meter. I love the groove object. Not groove duck, groove. I give that the name lip. And groove just lets us do some slightly more complex things. Rather than giving it a start and stop, it actually just wants a signal for a constant playback. And this signal is like, it just converts it to something that is basically one of these yellow patch chords. But if I give it a 1, zero means it'll stop. One means it plays at 100% speed. Where are you? There you go. 0.5 means it plays at 50% speed. 0.2 equals 20%. And here's something fun. -1 equals 100% reverse speed. And so you can get those kind of like deep, kind of like voice, like singing like this, chipmunk kind of sounds. But one thing I love with this object is you can do something called time stretch. I could just do it like this, I guess. Time stretch $1. And what this will do is it lets you slow down and speed up the file, but it'll readjust the pitch to work with what it was before. So I'm gonna just
At first we started out real cool.
And that becomes like so much more dynamic in terms of like something that you probably haven't heard before. Or like, yeah, maybe you have heard before, but like you're building your own system now to like play with audio and do it in real time. And like anything else in Max, this number right here that's driving everything can be hooked up to countless other things. So yeah, there's other objects that work with buffer. There's also like 2D wave is an interesting one. But So I think if you go into the buffer help, you'll see that it's like there's a lot of different things going on you can play with. Also, like look at here. Most of these objects are working with buffer. You can also record sound into a buffer so that you could you could record yourself speaking and then play with that, and then record that and play with that. I have some. I'm not going to go into all of them at the moment. One, I'm like realize it's very hard to like do this when I can't hear what the computer is making, but this just gives you an idea of like where to start. And with the GitHub examples, they actually go into a little bit more depth about how to set up some different things. So have fun with that, enjoy, and I'll see you guys in class.